So far we've managed to generate a CSRF token when we start the session. We've used that as the value in a form's hidden input. What we want to do now is take care of actually verifying that CSRF token when we submit the form. So let's go back to ChatGPT and see if it can help us a little further. So this is the information that it gave us regarding validating the CSRF token. So it says when the form is submitted, compare the token from the form with the token stored in the session. If they match, the request is valid. Otherwise, it's likely a CSRF attack. And it provides us some code. The code is fairly straightforward. It's saying if the CSRF token in the post data doesn't match the CSRF token in the session data, then that's a potential CSRF attack and we need to handle that. And so we'll think about how we're going to handle that later on. But first off, something which is missing in my mind here is where should I actually put this code? Because it's not something which I want to put in every single controller method which handles a form, because that would be a lot of duplication. So we might have ideas of our own how we're going to handle this. We might want to design some kind of component, or we could just ask ChatGPT, how does frameworks like Symfony and Laravel handle this kind of thing? Because this problem has been solved before us. We're not the first person to solve this problem. Let's find out how others do it. We might be happy with that. We might be able to go with those solutions, or we might be able to use them as a little bit of inspiration for our own. So here's the question that I'm asking. I'm mentioning, I've said to chat, you gave me this code for verifying CSRF tokens, and then basically I just want to know the answer to this. I don't want to duplicate this in every controller action which handles a form submission. How do other frameworks like Symfony and Laravel handle this? Let's see what it says. So this is the answer that it's come up with. It tells me that I'm right, that copying and pasting verification everywhere in the application is neither efficient nor maintainable. And then it explains how frameworks like Symfony and Laravel handle this. So Laravel, first off, it mentions CSRF protection is enabled by default for all HTML forms, blah, blah, blah. And it explains you drop the token in the form. Yep, we're already doing that. And it actually says that Laravel uses middleware. And so this has caught my eye because we've built a middleware system into our framework. So this could be maybe the easiest way to go, or the most logical way to go if we already have a system which we can just throw another component into there. So the back of my mind, I'm starting to think that could be the solution, but I'm not ruling anything out. Let's see what it has to say about Symfony. So Symfony, the way this works, again, Symfony provides CSRF protection that works similarly, but with its own syntax. And the way this does it is it uses a token in a form. It says when using Symfony's form components, CSRF protection is enabled by default. This means a CSRF token is automatically generated and validated without you having to manually set it. And what they have is a CSRF token manager. And I'm seeing here they have their own CSRF token class. So we're creating quite a lot of new components here, which we don't already have. So I think what I'm going to do is keep life simple. I know I have middleware. And so let's just go and create a middleware component which can handle this for us. And so I'm just going to ask Chat to show me a Laravel style middleware component which can verify CSRF tokens. Let's see what kind of code it produces and see if there's anything we can take or use as inspiration. And this is what it's come up with. It's not great code. Some of this nesting is ugly. Also, it's a little bit simplistic, but we can get some ideas from this, mainly just by looking at the comments. So it's saying check if the request has a token and the session has a token. Oh, okay, so there'd be pointless checking to see if there are matching tokens if we're not actually posting a token, or if one is not set on the session. So that makes sense to me. And then we're just going to compare the tokens. Might use something a little bit more sophisticated to do this comparison, but we'll get to that shortly. And I think what I'm going to do is, if the tokens don't match, I'm going to throw an exception. I'm going to come up with a dedicated exception for handling this. But again, if everything is okay, then all we're going to do is we're just going to forward the request onto the next piece of middleware. So over to the code, and let's go and start to create our middleware. So inside of the framework folder, inside of source, if we remember, we had this HTTP folder, and inside of there, we had our middleware. So let's just add a new one inside of there. So PHP class, and this will be called verify CSRF token. Okay, and this will implement our middleware interface. And so there we need to make sure that we're adding our one and only method, which will be process. So just a reminder here, process has two parameters, the first one being the request, the next one being request handler interface. And that of course is what we want to delegate to if we're happy to pass the request on to the next piece of middleware. Let's drop those steps in here first off. Okay, so these are the steps that I've come up with. They're fairly straightforward. The first one, proceed if not a state change request. What do I mean by that? Basically, I don't want this to be stopping the process if it's just for a GET request. It's only for state change requests. So if it's a post, a put, a patch, or a delete, then go ahead and check the tokens. As the application grows, you might want to have something a little bit more sophisticated than this, but I think for the time being, that should suit us okay. Next, retrieve the tokens. So I want the token from the post data and from the session. Then I'm going to check those, and I'm going to throw an exception if there is a token mismatch. Otherwise, what we're going to do is we're just going to proceed. And how do we proceed? We pass the request into the request handler, and via that route, it will be passed to the next middleware. Okay, so I think we can make a start on this. If the request method is not any of these, we shall say return request handler handle request. Otherwise, we want to retrieve the tokens. And we can say token from session request, get session, and then get, and it is CSRF token. And then we want the token from the request. So we can say request input, and it was underscore token. And then what we want to do is check to see if they match. I'm going to use a PHP function called hash equals for this. I'll show you what that looks like in a sec. So hash equals token from session, token from request. If they don't match, what we want to do is throw an exception. Okay, so hash equals, what is this all about? So this is what the docs tell us. It tells us that it is a timing attack safe string comparison, but it doesn't tell us any more than that. So we could go to the documentation, or we could go and ask our friend ChatGPT, because we know we can't ask the documentation questions, but we can seek clarification with ChatGPT. So I tend to prefer that over the documentation these days. So this is the question that I'm asking. Please can you explain the hash equals function in PHP? Would it be a good idea to use this to check my tokens against each other? And so this is what it says regarding hash equals. The hash equals function is used to compare two strings in a way which is resistant to timing attacks. A timing attack is a type of side channel attack where an attacker tries to compromise the system by analyzing the time taken to execute cryptographic algorithms. It gives a little bit more information regarding this. It says hash equals is designed to prevent this by always taking the same amount of time regardless of the content of the strings. It does a constant time comparison. So is it a good idea to use this? Given the purpose of CSRF tokens and the importance of their secrecy, using hash equals to compare CSRF tokens is a good idea. Even though timing attacks are more commonly associated with password hash comparisons, it's a best practice to use constant time comparison functions like hash equals for any security critical string comparisons, which of course a CSRF comparison is. So we've said if they don't match, we're going to throw an exception. We're not going to do that in this one. What we'll do in this one is we'll actually just dump it out, and we'll dump out the two tokens actually. So token from session and token from request, just so we can have a look at them and just see with our eyes that they are different. If everything has gone well, then down here we're going to do the same as what we did for the previous proceed step, and that is just return request handler request. And what that does, if you remember, is it will then just pass that request on to the next middleware. We're going to have another look at the request handler anyway, because we need to go and add this new middleware. So let's look for that request handler. And so first off, let's have a look at that logic which we were just speaking about. So we get the next middleware class to execute. We obtain the middleware class from the container. So that comment needs to live above there, I think. And then it says we just call middleware process. And so that is the method which we've just been working on there. So basically that is calling this. And then if we need to proceed to the next middleware, we go back to the handle method, which is this, checks that we still have middleware in the stack, and then again, just calls the next one. So array shift this middleware, moves you on to the next one, get the middleware class from the container, and then call process on it. And so eventually somewhere in that sequence, one of the middlewares will actually be able to return a response. Okay, so that was just a quick refresher. What we want to do here is actually drop our verify CSRF token middleware into this middleware array. So the best place for us to drop this, I think, will be after the start session middleware. So verify CSRF token class. So let's go and submit a form. The first thing I'm going to do is I'm going to make sure that we have mismatching tokens. And so if we have mismatching tokens, it means that this will evaluate to true, and we should see the two mismatched tokens here. So over to our login form, I'm just going to log in here, submit. Okay, so as you can see, we have our fake token and we have our real token. Let's go and revert this to how it was. And we're just going to try the form again. Okay, and that worked, and it's now telling us that we are logged in. So we have a mostly working system. We had a solution from ChatGPT that showed us that we need to check one token against another, but we weren't sure where to put that. So we asked it how other frameworks do this, and it notified us that in certain cases, middleware is used to check CSRF tokens. We knew that we have a middleware system in place, so it just seemed like the perfect place to put this. All that is left for us to do is to just handle those scenarios where the tokens don't match, and we're going to have a custom exception which will deal with this for us. We're now into the final steps of our CSRF prevention, and that is to handle the scenarios where the two tokens don't match, i.e. the token that we get from the request in the form that we post and the token which is generated on the session in the session start method. And so what I'd like to do to handle this is to create a specific exception. So we'll create an exception called token mismatch exception. But if we remember how our exceptions actually work, what we want to happen here is we want this to be caught and have some kind of graceful response. Let me show you what I mean. So this is actually handled in our HTTP kernel, and it's in this method here where we create this exception response. So in dev and test, what we're going to do is we're going to rethrow that exception. But if we're in production, there's a couple of different paths we can take here. If our exception is an instance of HTTP exception, then that suggests some kind of user error or something which has been instigated, triggered by the user, such as not sending a token or sending a fake token. That will be something which has come from the user's end, whether they know that or not. So really, we want our exception to be handled by this. So in that case, we will make our exception extend the HTTP exception. Just for thoroughness, let's remind ourselves of the other path, and that is if the error is something which is unknown to us, i.e. it's not an instance of HTTP exception, it's not something which we've put some special kind of handling in our code for, then we'll just send back a response with a 500 status, just saying server error, no more information than that. Back to the verify CSRF token middleware, and so this is where we're going to throw that exception. Let's go ahead and actually create that exception. All of these exceptions, the HTTP exception and its child classes, child exceptions, have been created inside of this HTTP folder, so let's do the same here. And we don't need to give it any extra functionality, we just need to actually create that exception class and make sure it extends HTTP exception. So this will be called token mismatch exception. Extends HTTP exception. Make sure you got the right one. It's in the same namespace. So namespace in my case, Gary Clarke framework HTTP. And then we'll go to the verify CSRF token and we'll just replace this with the real code. So first off, I'm going to create the exception because remember how we've done this before. We created it and then we set a status code on there. In our case, we're going to use a 403 status code, which means forbidden, because the user is trying to attempt something, which in this scenario, if the tokens don't match, then it should be forbidden. So 403 makes sense here. And we shall just say your request could not be validated. Please try again. We don't need to give any more information than that. Then we'll say exception set status code. So we only seem to have one status code on the response at the moment. Let's actually go and add a new one here. Just going to call it HTTP forbidden. And that has a value of 403. And then all we do once we create the exception, set a status code on it, is we just throw it. Okay, so let's once again go and make this a fake token. So I'm just going to comment that out. And then what we should see here, because we're actually in dev mode, we should see that exception surface. So over in my browser, I'm going to go to login, enter some credentials, click submit, and then hopefully this is what you will see. Uncaught, Gary Clarke framework HTTP token mismatch exception. Your request could not be validated. Please try again. So we know that this is definitely working. And so the reason why we're seeing that exception is because we are in dev mode. How about if we go to the .env file and we change this to prod and then we attempt the same thing. So we're still using this fake token here. Going to enter my creds again, click submit. Okay, so this is how it is handled if we are in prod mode. Instead, the message gets passed into the response and then here it's just been echoed out onto the screen. So that's the message, and the stage which we hit was this. So the exception has been caught here and a response has been sent back, and the message was the exception message and the status code was the exception status code. One more to go. So let's go back, change this. So now we are comparing the real token from the request with the real token from the session. And we'll just go back and submit the form again. And hopefully this time we should be able to log in. Okay, perfect. And that completes the feature. It's vital that your applications have protection from cross-site request forgery. The way we've built it means that it was very easy for us to implement this. Let's remind ourselves of the steps. So the first thing we did was we went to the session start method, and all we did was we checked, do we have a CSRF token on the session? If not, we just generated one and set it. Then what we needed to do was actually add this to a form. So you need to add it to any of your forms in your site where a user is submitting data. Very important. It's just a hidden field and the value is set to that of the session's CSRF token. And then the final step was to actually check it on the back end. So we had a bit of a dilemma of where to put this. We weren't really sure at first, but then we did a bit of research. We saw that Laravel actually uses middleware for this. We've already built a middleware system, and so all we needed to do was just add one class. All the information that we needed to make this work was actually held on this class because we're passing in the request and the request has access to the session. So everything just fell into place really nicely for us. And then we just created one final class. We decided that if the tokens don't match, then something malicious is potentially going on here. And so we're just going to throw an exception and not let the request go any further. If everything had gone okay, then we would have jumped past this point and the request handler, the request would have been passed into the handle method of the request handler and then subsequently sent on to the next middleware. And that's how this bit works here. Array shift, okay, get rid of that middleware, move on to the next one, get the middleware class from the container and call process on it. And as you can see, all our middleware classes, they implement the middleware interface, and so they all have a process method which accepts a request and also the request handler. I hope you've enjoyed this one. If there are any other features you'd like me to add to this framework, then just drop a message in the comments and we'll see what we can do together.